Let us discuss this example. So in this example, we have a set of complex numbers, right? So you are familiar with a set of complex numbers, since I think in 12 we have already seen. So set of complex numbers means what? We have, I will write, we have set of complex numbers, that means the numbers, okay, normally we denote it by z, which is in this form, x plus iy, where x and y both are real numbers, right? For example, 2 plus 3. So it's a complex number. I is there. I hope all of you are familiar with I. I means square root of minus 1, right? So I represents square root of minus 1, imaginary number. And if we have a number like this, 2 plus 3i or a plus ib, so we call it as a complex number. So in this example, we have a complex number, set of complex number, and we have to prove that it is a non-linear space. See, the norm is defined in this way, okay, and I will clearly mention. And see, norm of z, they have mentioned it is square root of, okay, absolute value. Absolute means square root of x square plus y square. So in this way they have defined, right? Norm z is equal to, that means norm of this one is square root of first, square of first plus square of second. In this way they have defined, and we have to prove that it is a norm. That means it should satisfy 4 conditions. First is greater than or equal to 0. Second, we have a 0 equal to 0 if and only if the number is 0. Third, if there is any constant or there is any scalar, we should able to take it outside with a mod. And the last one is, that means norm a plus b less than or equal to norm a plus norm b. So let us start to prove it, okay. See, the first condition I will start. See, for if you take any complex number, z is equal to x plus iy. So this is one complex number I am taking. See, x and y, okay, implies x and y, these are real numbers, getting? So if you have complex number but x and y are real numbers, so if you take their squares, if you take squares of any real number, cannot be negative. So y square is also greater than or equal to 0. If you have non-negative numbers, then if you add, you will have non-negative number. That means x square plus y square, again greater than or equal to 0. After that, what will I do? I'm trying to bring that definition here, getting? So see, what will I do? I will take square root of both sides. But when you take a square root, we will take, see, obviously when we take a square root, there will be two possibilities. Either square root will be negative or square root will be positive, but I am considering here positive square root. So implies square root of x square plus y square, this is greater than or equal to 0. So I will mention by considering positive square root, okay, by considering positive square root, right? Okay, see, this is nothing but definition of z, right? So therefore I can write, okay, we have a lot of space on this side, so I will write here. So implies norm z greater than or equal to 0, and this is true for all z belongs to C. For any arbitrary z, we prove that its norm is greater than or equal to 0. So in this way, we have proved that our norm satisfies the first condition. So let us go for the second condition. What is second condition? In second condition, what we do? So we consider, okay, in second condition, what we do? We consider norm z is equal to 0, and our target is to prove that z is equal to 0. So let us start to do. If and only if, I can write if and only if, see, if and only if, let us simply apply the definition norm z, that means I can write square root of x square plus y square is equal to 0. After that, you can also tell me what we have to do after that. Obviously, we have to take square of both sides. So if I take square of both sides, we will have x square plus y square is equal to 0, right? We are adding two squares and we are getting 0. That means obviously each of them should be 0, since squares cannot be negative. So the only possibility is x square is 0 and y square is also 0. So tell me a number whose square is 0. Obviously the number should be 0. So that means x is 0 and our y is also 0. That means our z, which is x plus iy, our z is x plus iy, that is 0 plus I0, that means z is also 0. So we started with norm z is equal to 0, and finally we got z is also equal to 0. So in this way we proved our norm satisfies first two conditions. So let us go for the third condition, but before that make a screenshot of this one, and after that we'll go for a third condition. Okay, so let us try for the third condition. So what is the third condition? In third condition we require one z. So I'm taking with z, which is obviously x plus iy, which is a complex number, right? Okay, and we take one scalar or real number. I will call it as alpha. Okay, so you remember the third condition, that is we start with, in third condition what we do, we start with norm alpha z, and finally what we want, okay, finally what we want, that constant alpha should come outside. So but when it will come outside, it should carry a mod. Okay, so let us start to prove. So this is equal to, obviously what will I do, alpha, right? What is our z? Let us write its value there. Z means our x plus iy is equal to, obviously I will multiply each of them by alpha. So we will have alpha x plus I alpha y, right? So let us apply the definition of norm. Definition of norm says square root of first, that means alpha x square, plus square of second, that means alpha y square, right? So square root of, see, multiplication is there, that's why we can take separate square. So alpha square x square plus alpha square y square. After that, alpha square is a constant, so we can take it outside. So we can take common actually, square root of alpha square x square plus y square, right? Multiplication is there in between, so that's why we can take separate square root. So what will happen, alpha has a square and we are taking its square root, so square and square root will get cancelled to each other, but always we consider positive square root. So that's why I'm writing mod alpha and square root of x square plus y square, right? So mod alpha square root of x square plus y square, this is the definition of norm, right? So this is the definition of norm z. So that means we started with norm alpha z and finally we got mod alpha norm z. That's why we can say our norm satisfies third condition also. So now finally we have to prove just last condition only, make a screenshot of it, and after that we will go for last condition also. Okay, so let us go for the last condition. What is last condition? Norm x plus y, or norm x plus y should be less than or equal to norm x plus norm y. That means if you take a separate norm, value will get increase, right? So here also I will take two elements. So fourth condition, for fourth condition I will take let z1 is x1 plus I y1. So this is first element, and z2, this is x2 plus I y2. This is our second element. Two elements I have taken. So let us start with consider norm z1 plus z2. Okay, so let us start to discuss. So first of all, obviously I will put their values. What is my z1? My z1 is x1 plus I y1 and z2 is x2 plus I y2. Do you know how to add two complex numbers? We add real parts and we add imaginary parts. So x1 and x2, they don't have I, so that's why we call them as a real part. So we will add them. So a real part, that means x1 plus x2, this is real part, and I we can take common and we can add y1 plus y2. After that, okay, after that what will I do? I will simply apply the definition of norm. Our definition of norm says square root of, right, square of first real part plus square of imaginary part. Okay, but I don't like square root. I think you also don't like square root, right? So what will I do? I will take square of both sides, so square root will be removed. So therefore norm z1 plus z2 square is equal to, I am taking square of both sides, so x1 plus x2 square plus y1 plus y2 square, right? So square, you know the formula of square, a plus b bracket square formula. Let us apply it and let us see what will happen. So that's why x1 square plus 2x1 x2, correct, plus x2 square. So let us apply the same formula for the second bracket. That means y1 square plus 2y1 y2 plus y2 square, right? After that, okay, after that I have some plan. What will I do? I will add squares. That means, see, I will show you what I'm going to do. So this is equal to x1 square plus y1 square. What I'm doing? x1 square plus y1 square. Similarly, I will form a second pair, that is x2 square plus y2 square, right? And the remaining terms are the terms having 2 as a multiple. So 2x1 x2 and 2y1 y2. Can I take 2 common? Yes, we can take 2 common. So if I take 2 common, I will have x1 x2 plus y1 y2. So this is equal to, see, this is, have you seen it anywhere? X1 square plus y1 square. If I write a square root, this is a definition of norm. So this is norm z1 square. You are getting my point? So norm z1 means what? Norm z1 means this is z1, no? So definition says this is square root of real part plus square of imaginary part. This is definition of norm z1. But we don't have a square root, so that's why I'm calling it as square. Or if I take square of both sides, we will have the same thing. What about the second bracket? What do you think? What do you think for a second bracket? Second bracket is x2 y2 we have, so that's why this is norm z2 square. I think you are not familiar with this x1 x2 and y1 y2. This is the definition of actually inner product. Okay, I think already I told you somewhere in our previous videos. Yeah, this is a inner product. So this is inner product of z1 comma z2. Okay, so yeah, this is inner product of z1 comma z2. After that, so there is one Cauchy-Squartz inequality. It says mod inner product of z1 z2 is less than or equal to norm z1 into norm z2. Okay, this is Cauchy-Squartz inequality. So this inequality I'm going to use. So this is less than or equal to, first term is same getting, I'm not touching to it. Second term is also same, but I'm just talking about the last term. Okay, for last term what will you have? This is less than or equal to, see, more norm z1 into norm z2. I should mention by Cauchy-Squartz inequality. Okay, Cauchy-Squartz inequality, short form I use. Okay, have you seen this? Okay, do you get anything by watching this one? So something square plus 2 into something something. Yeah, this is a bracket square formula. So this is expansion of norm z1 plus norm z2 bracket square, right? So that's why finally what can I write? Therefore I can simply mention, therefore, yeah, our left hand side, don't forget our left hand side is norm z1 plus z2 square less than or equal to, only one time we have got less than or equal to, and norm z1 plus norm z2 bracket square. Okay, so to remove the squares, I will take square root of both sides. So obviously I'm taking positive square root. So norm z1 plus z2 is less than or equal to norm z1 plus norm z2. Okay, so in this way we can say the last condition is also satisfied. Getting, so all conditions are satisfied, therefore we can declare it as a norm on C, set of complex number. Make a screenshot of it, and just I will remove this part and I will write. Please make a screenshot of this one. Okay, see here clearly I mentioned all conditions are satisfied, therefore it is a norm on C. Okay, so example is over. Thank you. Make a screenshot of just 2 sentences. After that we'll stop. Thank you.